Hey everyone, I'm Keaton, and today I want to walk you through a project I built called Performance Lab. Here's the problem this solves. When you're developing software for complex, creative workflows, think video editing, music production, or code compilation, every commit can potentially introduce a performance regression. Maybe a new feature causes the CPU to spike, or memory usage might double, or an export that used to take 8 seconds now takes 12. If those regressions slip to production, millions of users can feel it. Performance Lab is an end-to-end platform that automates benchmark execution, detects regressions statistically, and visualizes performance trends, all triggered on every commit through CI/CD. It's built with Python and Fast API on the back end, React and TypeScript on the front end, InfluxDB for time series storage, Grafana for dashboards, and GitHub Actions for CI, so it touches the full stack. Let me walk through how this system is architected. At the top, we have a React and TypeScript dashboard. This is where engineers interact with the system. They can configure benchmark parameters for each application, trigger pipeline runs, and view results. The dashboard talks to a Fast API backend over REST. The backend orchestrates everything. It manages benchmark configurations, handles Git operations, and queries metrics from InfluxDB. Each monitored application lives in its own GitHub repository. Right now, the platform tracks 3 apps: a mock Final Cut Pro, Logic Pro, and Xcode, representing video editing, music production, and build system workflows. When the backend pushes a config change to a mock repo, it triggers GitHub Action workflow. That workflow runs the benchmarks, writes the resulting metrics to InfluxDB, and performs z-score regression detection. If a regression is detected, the CI run actually fails, so it acts as a quality gate. Finally, Grafana pulls data from InfluxDB and renders per application dashboards. These dashboards are embedded directly in the React UI via iframes, so engineers get a single pane of glass experience. The architecture mirrors how a real performance engineering team would operate: per application repos, automated CI benchmarks, centralized time series storage, and dashboards that update on every commit. Now, let me show you the dashboard. We have 3 tabs at the top, 1 per application. I'll focus on Final Cut Pro. Each app has multiple workflows. For Final Cut, we have importing video, editing video, and exporting video. Each workflow has 3 metric sliders: CPU usage as a percentage, memory usage in megabytes, and execution time in seconds. These configure the mean values for the benchmark simulation. In a production system, these values would come from actual instrumented measurements, but the simulation approach lets us tell controlled performance stories for testing and validation. Below the sliders, there is a commit message field and a commit and push button. This gives the experience a developer-like flow. You adjust parameters, describe the change, and push. At the bottom, we have a regression detection table. This shows any anomalies flagged by z-score analysis, with severity levels, z-scores, baseline comparisons, and the commit that introduced them. And here is the embedded Grafana dashboard. We'll come back to that in a moment. Now let me show you what happens when a code change introduces a real performance regression. I'll simulate adding an AI scene detection feature to the import pipeline, and it's going to cause a significant performance hit. I'm dragging the import CPU slider from 40% up to above 70%. The memory from 900 megabytes up to around 1500 megabytes. and the execution time from 3 seconds up to above 6 seconds. Notice that I'm only changing the import workflow. Editing and exporting stay the same. The regression is isolated to one workflow, which is realistic. I'll type the commit message, add AI scene detection for imports, and click the commit and push button. The backend just wrote this configuration to the mock repo, committed it, and pushed it. That push triggers GitHub Actions CI pipeline. And look, the CI run failed, not because the code is broken, but because the benchmark runner detected a strong statistical regression. The z-scores on all 3 import metrics exceed 3.0, the threshold. This is the quality gate in action. A developer would see this failed check on their pull request and know they need to investigate. Now, let's take a look at the Grafana dashboard. The dashboard is organized by workflow. Each row shows 3 time series: CPU usage, memory usage, and execution time. Look at the import workflow. For the first 16 commits, you can see a stable baseline. CPU hovering around 40%, memory around 900 megabytes, execution time around 3 seconds. Some natural variance from the simulation noise, but the trend is steady. But right here, at commit 17, we see a dramatic spike. CPU jumped up to around 70%, memory shot up to around 1500 megabytes, and execution time went from 3 seconds to nearly 6. That's the AI scene detection feature we just pushed. See these red markers? Those are regression annotations. The system automatically annotates the dashboard whenever a z-score exceeds 3.0, so you can visually correlate performance changes with specific commits. Meanwhile, the editing and exporting workflows are comparatively flat. This tells an engineer that the regression is isolated to the import pipeline. They know exactly where to focus their investigation. The regression table below provides the raw data, the z-score for each metric, the baseline mean, the severity level, and the commit that triggered it. This is everything an engineer needs to prioritize and triage the issue. The detection uses a sliding window of the last 20 data points, requiring a minimum of 5 for statistical significance. A z-score above 2.0 is flagged as a possible regression, and above 3.0 is a strong regression. So to recap, Performance Lab is a full-stack performance monitoring pipeline. It automates benchmark execution on every commit through CI/CD. It detects regression statistically using z-score analysis with configurable thresholds. It visualizes performance trends over time with embedded Grafana dashboards and regression annotations. And it gives engineers the data they need to quickly identify, triage, and fix performance issues before they reach end users. The project covers the full engineering stack, from Python and Fast API backend and React and TypeScript frontend to time series data engineering with InfluxDB, CI/CD automation with GitHub Actions, statistical analysis and data visualization with Grafana. Thanks for watching, and feel free to take a look at the Performance Lab GitHub repository at github.com/thatdspguy/performancelab. Thank you.